Right, welcome. Another episode of Mickey J. Whitehat. Thank you very much for all those new subscribers. Thank you for joining me on this crazy journey. Today we're going to talk about another in the Foundation series, which is packet sniffing. Yes, you've all probably done it, you've all probably seen it, but how can you turn packet sniffing on its head to find malware? Stay tuned after this, we'll go through some packet sniffing. So, packet sniffing, what exactly is it? How does it help you? What can you do with it? Packet sniffing is all about inspecting all the data that's going through your interfaces. You can inspect the frames and the packets. You can see everything that's going on your network. But some of this magic doesn't just happen. You have to do some stuff to prepare for this. One of the things that I do, personally, is I work out where everything on the network has to go through. So it might be a switch or a router or something like that. And in the middle, I stick a hub. Yeah, you got it right, a 10-base hub. Sometimes I've seen a 100-base out there, but why a hub? Well, the ports on the hub are not intelligent. It might be an 8-port hub, but it broadcasts the data across all the ports the same. So on my port, let's say I'm plugged into port 8, I'm seeing everything from 1 through 7. I'm seeing every conversation from every computer. I'm seeing the network. Now, that's the old school method, but you could also put in a super fancy switch, and you could tell it to mirror the switch port. On some routers, you've actually got the ability to packet sniff on the hardware and then dump down the file. One of the things that's been more recent is a thing called WinPcap, which funnily enough installs with many packet sniffing products. And WinPcap has a thing in it called promiscuous mode, where it sits back and listens. And what happens is the software actually can listen to some of that stuff going through the other ports. It listens to all. So hubs and mirrored switch ports and things like that, they're important, but going forward, maybe not as important as I once thought they were. You can packet sniff in a number of ways. You can packet sniff at some routers. You can packet sniff with your PC and some software on there like Wireshark or TCP dump or something like that. And you could also packet sniff simply by using a online sandbox, say for instance hybrid analysis, which will packet sniff the actions of the virus you've just put up as a sample. So today we're going to go through a few things. Now, before we get started too far, I'm expecting that you know a little about TCP/IP. I'm expecting you know about the OSI layers, that you know that the application layer, the GUI, the thing in the front, is the 8th layer. And then you've got the presentation, which is the stuff that gets presented to the GUI. That could be MPEG or JPEG or MP4. There's session, which manages your connection. There's the transport, that's the good stuff. That's the TCP/IP, the UDP, and all the error correction and things like that. Then you've got the network layer, which is your fancy, expensive routers. Then you've got your data link, which is your MAC, your Ethernet addresses and bridges and things like that. And then you've got the physical. Can't get away without the physical, and that's the cable. The only difference you might add to this is when you do wireless, you're also adding in things like channels and things like that. And as we're about to enter Wi-Fi 6, which is just around the corner, I think it's 802.11ax, that's going to get a little bit more complicated yet again. I'm going to use Wireshark today, and in Wireshark it does follow the OSI. You can drill down each of the different layers. So how about we get started, hey? This episode brought to you by The Virus Doctor, so be sure to go and check it out at The Virus Doctor. The Virus Doctor, he's all about removing what I find. He removes all those little things that I pull apart. He shows you in 4 easy categories and some easy steps how to pull things apart. So go and check out The Virus Doctor. Without him, this episode wouldn't be possible. Okay, so here we are in Wireshark Network Analyzer, a free tool. Used to be called Ethereal, and there are other products out there as well. Wireshark is available, of course, for Linux and Mac and things like that. Great product, free, download it, run it, it's all good. Now, you can see that I've been doing quite a bit here. There's quite a few in my recently opened list. What I am going to do is I'm actually going to open up just any one of these. Double click, so you can see what the Wireshark interface looks like. First thing to note is this section here, where you've got the frame number, packet number I should say, the time, this is the time since you started the packet sniff, this is the source of the packet sniff, the destination where it's heading off to, the protocol, the length of the data, any information about that. Now, this is stored in pcap format. This is a download actually from a router. The hybrid analysis, the packet sniff, can be sucked into this as well. One called TCP dump, one called raw dump. They can all be put into this in pcap format, so you can open up packet sniffs from other products. So up here you're seeing the actual packets, but as you click on each packet, the information in the other windows changes. What we have underneath is the OSI layers. So what you have at the very top, you can see you can drill down into interfaces. You can drill down and see that this is, for instance, going through a sonic wall firewall. You can see a little bit of information about the physical level. You can see all the bits and pieces. You can see what protocol it's using. So I can see that I'm using version 4, so IPv4. I can see my IP address. I can see MAC addresses, all that kind of thing. I can see what protocol I'm using, so NetBIOS name service there. And then, of course, I can actually see a bit more detail about that as well. And down the bottom here, well, that's the hex dump. That's what it looks like. So that's what it looks like over the wire. But, of course, that gets interpreted by all these things. At the moment, not a great lot of use to us, but we've got the packets up here, information in the header of the packets here, and what it looks like down here. So I don't really need to see that. That's beyond what I need to know. I'm not really interested in that at the moment. This is the stuff that's of interest to me. There's a few things we can do here. Wireshark has a built-in tool for doing web analysis, checking to see why you're getting those phone calls that are dropping, things like that. Down here you've also got anything that went wrong. So you can see that there was a DNS query tree transmission. So you can tell whether your network's stable or not if there's any problems. Doesn't really help us from the malware perspective, but you never know, you might be able to fault find some other stuff as well. And of course here at Mickey J. Whitehat, we're all about pulling apart malware and seeing how it got in the system. There's all kinds of analysis and statistics tools. You can go in and you can find out, for instance, conversations. So which two computers have been carrying on about what and how they've been doing it. Now this is the raw data, but there are a couple of things you can do. You may hear the word BPF. Well, just think of it as display filters and also recording filters. You can actually change what is recorded at the time of starting your capture by changing the filter in it, and of course you can also change what is displayed by changing up here. Now at the moment I have a filter on, so let's turn that off. Alrighty, so up here you can put all your various filters. Filters can look pretty crazy. There's a pretty much standard format for those filters. I'm at the moment going to use them as I need them, so I'm not going to show them to you right now, but I'm going to take you through a basic packet capture, and then we're going to have a look at a bit of analysis. So basically the capture is quite simple. You click on capture, you click on options, you choose your connection. Now I've turned off my Ethernet ports at the moment, so I've just got the wireless to choose from. Enable promiscuous mode because I do want to look across the network as much as possible. You can choose to break your output up into little files if you wish, and you can also resolve things like MAC addresses and various protocols and things like that. At the moment I just want everything, so I'm going to click on that, click start, and bang, it records this file that I've now got open. Now from this file I can tell a wealth of information. Now going back to these display filters, why would you want to use them? This information is pretty verbose. You're seeing everything from ARPs going on in the network through to some printer that's looking for something. Someone's got a light on. I don't even know what that is. I'm assuming it's a brand name of a product that's trying to query my wireless network, so I might look into that a bit later. But you want to filter out all the junk. I'm just going to put a display filter in here. And as you can see, it's now whittled down and removed a whole heap of the junk out of my listing. So what I've got here is I've got, obviously from learning from the website, how to formulate this, and I'm not going to do that in this particular video, but IP address, so I've chosen what IP address I want, and I don't want to see anything on HTTPS. At the moment, that's simply because it's encrypted. There's no point looking at it at this point in this demonstration. And I don't want to know about DNS, and I don't want to know about port 25 or 50, and I don't want to see ARPs, and I don't want to see NBNS. So at the moment, as you can see, I can string things together. I can use the equal sign, I can use the not equal, which is the exclamation equal, and I can use and symbol, the ampersand for and, or I can use the words not and things like that, and string these things together and ultimately I can make what appears in this window a lot less. In fact, that comes out quite good because I can see that I've got Dropbox installed here, and I can see a lot more than I could before because there's a lot less to look through. At some point I've been doing a bit of a ping. There's echo requests there, and there's Microsoft Search going out to the internet. So I can actually see quite a bit here without seeing all the chaff. Right, that's about pretty much all I'm going to show you about display filters, because there's a great help file on it, great website, and all you need to know is what you type in here is what appears down here. It doesn't delete it from your packet dump, it just hides it from your packet dump. If you want to geek out at a whole new level, different to me, you can go down to this hexadecimal section down here and you can change the way it is viewed. You can choose to watch it as bits, which is way above what I need. You can change it to view as ASCII or an IBM format in the early days. You can change it to that format as well. So you can mess around a fair bit with the interface. You can also go up here and you can also add a column in called expert, which will show you expert information that's sort of hidden from view. If you dig down, if there is any expert information, it appears in here anyway, but it just puts it in a column by itself. Needless to say, you can actually massage and change the interface of Wireshark to suit your needs. And today I'm not going to go into it because I'm going to look at some malware. Before I do that, just some basics about the Wireshark. Note all the different colors. Different protocols get different colors, just makes it easier to read. You can change those colors in the settings if you like. That's the first thing to note. The second thing to note is if you wish to see what's going on. So if I just change my filter to TCP and I choose, I don't know, not want an acknowledgement, this will do for the moment. If you want to see what this packet's doing and linking it to the next packet and packet thereafter, you can right click and you can follow the TCP stream and it will come up and give you the whole conversation. So there's stuff in red, that's my machine requesting something. The stuff in blue, that's my machine getting an answer for something. And as you can see, it's all signed and encrypted and all the rest of it. But that's how you generally work out what's going on, is by following these conversations of red and blue to find little snippets of information. You might see some clear text passwords, you might see all sorts of things flowing over this network. You can also work out what SMB protocol it's using, and quite often you can work out workstation names and you can work out workgroup names and things like that. If you really want to get a great idea about what's going on, you can go up to statistics and down to IO graph, and it will graph what's actually going on for you. In this case, not a lot, because it's only a very small packet sniff. There's something that has occurred here, and you can enlarge to find out what that is. But that's a great way just to get an overview without going through the raw data to see what's actually happening. The other thing you can do is go to Analyze, and you can go down to Decode As, and you can tell it to decode certain things, so that you can pop out various data in various different ways until it makes sense to you. As I mentioned before, there's always expert data hidden behind everything, so you can go analyze expert information and you can see all the errors and warnings, things that are going on the network, which is exactly the same as if you double click on the little icon down here. And you can obviously work your way through the toolbar yourself, and you can see that you can export packets and you can also join different packet dumps together. You can actually jump between and find different references. You can go to the last packet, the first packet. You can capture a new packet dump. You can analyze it further. You can check all kinds of statistics to see how many times DNS gets used and what IP used it. Again, the telephony, which is great, and wireless as well, and also Bluetooth devices as well. And you've got other tools here as well. So you can have a bit of a play with the interface and find out what it does for yourself. Today, again, we're here to have a look at some of the telltale signs of malware. I'm just going to close this particular packet dump down and open another one. Now, you've seen me pulling apart malware using hybrid analysis. If you're a logged on authorized user, one of the little cool things is it actually gives you the pcap file. So this is a packet dump. So I've uploaded this virus, it's run it in the sandbox, it's done a packet sniff during the process. What I'm hoping to see, I know I won't, but what I'm hoping to see are these class files. And also there's a DLL file that gets spat out, and there's also an exe file. Hybrid analysis don't allow you to download these things, and what I'm hoping is that their packet sniff contains enough information to be able to pull these files out of the packet sniff so I can then decompile them using Ghidra or something like that. So we go up to the hybrid analysis, we upload our file, we let it do its thing, we come along, we download the pcap file, and then we go and open it with our Wireshark. I'm now going to go and open that file. This is the packet dump that hybrid analysis did when it ran that particular virus. It's interesting because I can tell a little bit about their system. I can see they're using IPv6. I saw somewhere in here VMware, so I know that they're using VMware for their sandboxing. And obviously I can see the virus and what it's done. One of those things you can do that's really cool, file, export objects, HTTP. I know that executable in DLL came down through HTTP. It's now up to hybrid analysis as to what they've edited in this pcap file as to what I'm going to be able to download. So if I click on export objects HTTP, anything in here related to port 80 traffic that involved a file, I'll be able to save it out to my hard disk. That could be a JPEG file, it could be an exe file. Anything that got transferred via HTTP, I'm going to see. Not HTTPS, that's all encrypted. This is a great way to dump out those things that are malicious. Here we go. Now, in my case, I've got a success.txt file, and as I click on it, behind, it's sensitive and it went to that spot. I've got some certificates, not much use to me, more certificates. I've got something else that detected that I'm obviously running Firefox and a few other things. Now, unfortunately, in this case, I can see nothing but certificates. I can't see the executable, I can't see the DLL. One other thing I might just try is I might try SMB. No, nothing there. So it didn't transfer and try and copy around my network. Nothing else here really going to help me. But anyway, I suspect what's happened here is hybrid analysis, being the good people they are, trying to prevent us from getting infected, have actually removed the exe transfer from the pcap file, allowing us just to see what happened, not the actual pull out the data itself, which is still fine. I'm happy with that. But we can go through this and we can actually find out how this all occurred and what it all did. If I was to, for instance, go into this one here, if I was to right click and follow UDP stream, look at this. I can actually see all the websites it's hitting in plain text, one after the other after the other. So I can actually see fairly much what's going on with this particular piece of malware. If we were to go to, let's find out a bit about that success file, shall we? If we go to export objects, HTTP, click on success, close this, that was coming through, HTTPS it says. Oh, here we go. And if we were to follow TCP IP stream, here we go, the file contains success. Success text contains success. So I've actually just seen a file I can pull out through the exports, but I've actually seen it at a packet level. And I've also seen the conversation going between two. So that's pretty cool. I like the fact that I can pull out the files. In this instance, not as cool as I'd hoped. I'd hoped to pull out the exe file. But of course, in my own sandbox with my own Wireshark, I'm not going to limit myself, and I can probably pull out that exe file. So let's move on to another example. Here we have another example. This pcap file contains a thing called the Aurora hack. This is a well-known hack, well-documented, and lots of people out there have already packet sniffed it. I can see here straight away that this was actually done on VMware, in fact VMware 07. So there you go. I can tell a little bit more about this than I probably should know. But I can see all sorts of information down here. But where it really gets interesting is looking up here. If I have a look through this, straight away, that's a bit odd. So what I've got here is two machines chit-chatting over the internet, having a HTTP request, and I've got a 302 moved here. That's something you don't normally see. So you might want to dig down a little bit deeper on that. So let's just follow the TCP stream on that. And that's what this is all about. It's finding things a little unusual. So you've got to get used to seeing the code so you can recognize the differences. So here we're talking about what we accept and what we want, what we expect. And as we go down, we've got to keep alive in there. Okay, a little unusual. First thing I've got to mention is this text. This has gone up and pulled down a HTML page, but that's not HTML. That's a BBS or JavaScript or something, and it's obviously obfuscated so that nobody can see what it's doing, which we could probably pull that apart later. And we got some variables. So this is doing something a little evil. Don't quite know what it's doing because I haven't pulled it apart to look at it. We got a GIF file coming down here, and it's pretending to be a GIF file. Interesting. And ooh, look at this, an iframe injection. So what this is doing, by the look of it, is it's moved your website you went to in your browser to another website or web link, downloaded and injected this into an iframe of the browser you're in. That can get nasty. So let's have more of a look at what's going on here. I'm just going to close that down. So something has come along. Here we go. This is interesting. Let's just follow this one as well. And this is just a bit before what we saw before. And this is, I think, where it's trying to change the website, as in point us to another website to download something. And that's even one step back before again. Very interesting. Alright, let's have a bit more of a look. So this is just acknowledgements. Yes, I've received this packet. Yep, I've sent that packet. No worries. Acknowledgements, acknowledgements, acknowledgements. We've got a bit of a plain text thing happening here. Let's have a look at what that is. That's the same stream that we had before. So we'll kill that off and keep going. As we go down, TCP window update, inflow. Why is this color? What's going on here? Okay, let's have a bit of a look at what this is all about. Whee! Okay, so this virtual machine is obviously running Windows XP, and somebody has gotten in as the administrator and run the directory command and created a passwords.txt file. Okay, so this is happening through an internet iframe. Someone's gotten on this machine, gotten elevated permissions, and is going through the directory listings of this hard disk. Did you think it would be as simple as that? So again, all I'm doing is going through and trying to find things which stand out and look a little different. Look a little wrong, you might say. Alright, so that's pretty obvious. That stood out. We saw straight away something going on there that wasn't normal. And we saw that all happened over HTTP traffic. Let's go to another sample. Okay, this sample is done on my network. And I've been a little bit malicious myself, you see, because I've actually run a batch file against my network and recorded its actions just to see how it all looks. So how about we have a bit of a look at that batch file? Right, now here's the batch file. So what I've done is, the first thing I've done is pause it. Reason is, I wanted this up on the screen and then enough time in the background to start my packet sniffing. Obviously, it doesn't matter in real life because you're going to be packet sniffing a whole stack of data and filtering out what you don't need to see. But in this case, for this demo, I wanted to keep it nice and trim. Doing a net view, so that's doing a net BIOS call. That's going to go out to the network. It's going to see who is on the network, what machines there are, and come back with all those names. Then I'm pausing it again. Then I'm doing a net use Z drive, and I'm mapping it back to myself on the loopback, and I'm going to $temp. So that should show up pretty obvious. And then what I'm doing is I'm actually piping some data across the network into a VBS file. Obviously, this could be quite malicious. This could also be linked across into your registry in the start run key. So this data, it could be dangerous. Then I'm deleting the Z drive so that you don't see what I've been up to. And then I'm pinging Google, just for the heck of it, so you can see what it looks like in the packet sniff. So let's see how that looks on the other end. Starting from the top, we've got a whole heap of NetBIOS queries, trying to find out who's on the network. Well, that would be the net view. And there's some ARPs going on because I'm asking who's out there. And of course, ARP needs to respond and tell me, yep, this IP got this one on it from the MAC addresses. As we scroll down, that's probably not as malicious, but somebody could be trying to grab all the workstation names on my network, and instead of going across to 127.001/temp/c$/temp, they could be trying to crawl around on the other workstations like a ransomware does. So as we scroll down a bit further, okay, we've now got some other responses here to Google DNS. That's just general chit-chat. My machine's just doing something here, querying the internet. As we keep scrolling down, there's some ARPs, nothing really. Oh, here we go. So there's the ping. So I've got the ping going out and the ping coming in. So the reply, request. So there's 4 pings when you standard run ping, and those form 4 pairs. There we go. So we can see the net view and we can see the pings. Okay, what about the 127? Oh, here we go, 127 stuff. So at the moment we've got, okay, just some negotiations, nothing too fancy going on here. Keep scrolling, and someone's trying to connect to a session. They're trying to connect to /127.001 IPC $. Interesting. And as we scroll a bit further, now it's going to $, which we know is part of the script. We keep going, and now it's going to the temp folder within that $. Then it's creating the 1.vbs file, and then it's using SMB2, which would be encrypted, so I'm not be able to view too much of it, to put data into that 1.vbs file across the network. And it's actually checking the files still open. It's adding more data, and it's actually closing the file now, and it's getting a response to say, yep, I've closed the file. It's also created a desktop.ini file, as you can see. Then it drops the network connection, and there was an auto-run.inf it looked for, and that's the end of the packet sniff. So we've pretty much seen what's going on. Now, to narrow this down even further, we could view just the NetBIOS stuff. NBNS. This is all the NetBIOS stuff. So this is all your net view. Going out over NetBIOS saying, who's out there? What's your workstation name? Where are you? What's going on? We could also filter via all the SMB traffic. And there's not much there. Why? Because I'm using SMB2. SMB2. Now that starts to get interesting. So we've removed all the other chaff. We're not seeing the ARPs or DNS or DHCP requests. We're seeing just SMB2. And now we can see much more concisely what it's doing. So you've got your $, opening files, closing files, 1.vbs. So you could be doing this on a switch, and you could be looking at the whole network, and then you could be seeing workstation A accessing workstation B and placing encrypted files on there, VBS files, exe files on there, ransomware, all that kind of stuff. You would see all that traffic. I'm using 127.0.0.1 because there's only one PC here to test this on. But it could be a normal everyday private IP, 10.0.0.2, 192.168.0.1. It could be any of that stuff. And it could be somebody also trying to set up a web server or FTP server on another workstation. You would see it all in here. If we were to try and follow this, it's all encrypted. Signing public key, blah, blah, blah. So you're not going to see too much. You know what's happening between those two machines, but you don't know too much what's going on. And that is obviously great for clear text and things like that because it's going to get knocked out and no one can view it. Now, I know this has been a crash course into Wireshark, nothing too deep, not going into the OSI layers because I'm leaving that up to you. Not going into TCP because I'm leaving that up to you. But what I want to show you, though, is that Wireshark, wherever you get your sniff from, when you put it into Wireshark, how you can pull it apart, how you can dump out files. Obviously, the things I'm looking for is HTTP requests that get moved or a little bit odd, any SMB traffic that looks a little odd between workstations, file names being transferred between the two, looking up any of the clear text stuff to find out what's going on, anything that's gratuitously ARPing over and over and over again, trying to find things on the network would be of interest, and lots of other protocols. So you can imagine just how many protocols there are out there. I've limited this by shutting down anything on my machine that's running, but you could actually find a number of really weird things in there as well. And as you also saw from the Aurora one, is you can actually dump out the complete VBS code or JavaScript code or whatever is coming down from the internet just by going into File and Export, or by following the TCP stream. So Wireshark, get used to it, get to play with it. Upload your malware samples to hybrid analysis, pull down the pcap file and have a look at it. Do your own Wiresharking. This is what it's all about. This is the malware side of things. You're probably not going to get too far just with Wireshark. You need to know some of the other tools. And it's great also to use things like hybrid analysis and virustotal to get a head start, so you know what IP addresses you're looking for, what domain names you're looking for, and of course on hybrid analysis it tells you what VBS files, text files, exe files, DLL files, tells you all that stuff as well. Gives you a bit of a heads up so you can jump straight in and go straight looking for them. You can use the analyze feature and all sorts of other things in here to narrow down what you're looking for. You can narrow down anyway if you know enough filters. So you could do not ARP and bang, there's no ARP in here. And you could do and not DNS. So you can get quite creative with the filters. I don't care about ICMP and not ICMP. So I'm now narrowing down to exactly what I want to see, which is great because it gets rid of all the chaff stuff you don't want to see. I don't really care about NBNS. I could filter that out as well. Or you could create filters from a particular packet or type of packet. So Wireshark, download it, use it, learn it, and you'll be miles ahead. So thanks for sticking through me. I know this is just a foundation series. I know it's not up to the level of some of the other stuff I do, but this is grounding in some of the things I do, and I felt this video needed to be created. So until next time, thank you again. Have a great day.